Welcome back. We're going to continue with our inverse functions. We're in section 5.1, and we're doing a little harder function now. This is has an absolute value, and we want to graph it. And so it says graph the equation by substituting and plotting points, then reflect the graph across the line y equals x to obtain the graph of the inverse. All right, so here we go. So we need a little bit of graphing skills. I've blown up the chart a little bit, and so let's start with f of x. Let's do it in blue. So let me put it right below. So if you have x and the function is the absolute value of x plus 12, this is going to be our function, and then we'll do the inverse function next. Now, if you plug in a 0, you get back 12. Yeah, no problem, right? Now, it's not going to get any smaller than that. That's the smallest you can make because that absolute value is always positive. But I want to do a few negative inputs. So how about let's do a negative 4 input, which would give us a 16, and a negative 8 input would give us a positive 20. It's because the absolute value makes the negative into a positive, and then you add the 12. Now on the other side, it's exactly the same. The absolute value of 4 is 4, and so you get 16. So 8 is 8, plus 12 is 20. So we just need to get those 5 points on our graph. So here we go, 0, 12 is right there. All right, and as we move away, at positive 4, we're at 16. At negative 4, we're at 16. I feel like that was a little bit off. So let me try one more time on that one. Negative 4, positive 16. There we go. There we go. And then our last two, 8 and 20, and negative 8 and 20. There's our graph. So it's a little V-shaped graph. It's the absolute value function shifted up by 12. Okay, now it's time for the inverse function. Let's go ahead and just put it over here. This is going to be our inverse function. And I'm not writing down what the formula is for the inverse function, although we could figure it out. Let's just think about what the values are. Sorry. Here we go. So let's figure out what the values are. So if your input is 20, your output is minus 8. If your input is 16, your output is minus 4. If your input is 12, your output is 0. If your input is 16, your output is 4. If your input is 20, your output is 8. It's very unusual. So we don't even know what the actual formula is for the inverse function, but we can know exactly where these 5 points are. Now, technically what's happening is we are reflecting that blue function about the line y equals x. This is the line y equals x. We're actually sending these points across that line. And the blue right here has the same slope as y equals x, although it looks a little steeper. So here we go with the red. So at 20, we are supposed to be at negative 8. So that's down here. Okay, now keep in mind there's a little bit of an aspect ratio difference here. This looks a little longer in the horizontal than it does in the vertical. So 20, negative 8. 16 is minus 4. So 16 goes to minus 4. Okay, and then at 12, we're at 0. Okay, and then at 16, we're also at positive 4 now. You're going to realize this is not a function. It just violated the function rule. So the inverse thing is not even a function. So it's an inverse relation. All right. For each input, there can only be a single unique output, and 16 has 2 different outputs. So and so does 20. 20 also has a value at 8. Let's see if we can find it. It's right there. And so there's our graph. This little piece right here is a reflection of that. And then this piece right here is a reflection of this about the line y equals x. So you can see there's a mirror along the middle here like that. All right, great. Let's hit a couple more of these real fast. This just says determine whether the function is 1-to-1. I would just throw that in your calculator and just see if it is 1-to-1. Now, we haven't talked about the definition of 1-to-1, but 1-to-1 basically means the inverse function, the inverse relation is actually a function. But what you can tell if you look at this thing, what you want to do is for every horizontal line. So let me take a screenshot of this. For every horizontal line, you want it to pass kind of a horizontal line test. You know how we have a vertical line test? Well, this is a horizontal line test for 1-to-1. 1-to-1 is basically the inverse relation a function. And so let me get out my pen. So horizontal lines, you want them just to hit once and only once. And so all these are just hitting once and only once. There's no duplicates anywhere along this domain. So so this is definitely a yes. It is a 1-to-1 function. X squared minus x to the fourth, not looking like it. So if you put that into your calculator, so I can kind of tell just by glancing at it, it's not going to be 1-to-1. Anyway, but let's look at a picture of it. What's wrong with it? See these duplicate. So the x. Let me get a screenshot in here. Edit, paste. So the horizontal line test. Now I know we're normally used to calling it the vertical line test. So for 1-to-1, we're looking at what's the reflection look like as far as function values, and this thing violates the horizontal line test because if you run lines through there, it hits multiple times. So when we do our reflection of this thing, it's not going to be a function, and so this is not 1-to-1. All right, I think I'll stop that video there and pick up in a few minutes. Thanks for watching.